Okay. So yeah, what I do before talking about the syllabus, I should talk about the recordings. I tend to record the lectures of all of my classes, not just this one, all of my classes, and I try to post them on YouTube, right? But this is nothing official, right? It really depends on how much time I have to work on it, right? To edit and post it online. So you can watch the lectures online if they are posted, right? But don't send me emails asking why this lecture was not posted. This is nothing official. I just do this to help you guys, and the point is don't take advantage of it, or don't take advantage of it, but don't abuse the system. That's what I mean. And yeah, so the recordings will be available. I will send you a link tonight or tomorrow morning, so you can have access. You can access all of the recordings and watch them again and again if you need to. Yeah, that's for the recording. Let's talk about the class. So this is advanced heat transfer, as I said. For this course, you need to have a good calculus background, and you need to understand differential equations. We don't really have an official prereq for the class, but this is a graduate course. This is a very theory heavy course, so you need to know the differential equations and mathematics behind it. And we really don't have the time to review the mathematics, but we'll try to review some of it. So make sure you know the mathematics. But if you have problem with the math, with the basics, please reach out to me. I'll try to help you as much as possible. I'll try to give you more office hours or give you some material that will help you understand the course better. Okay? So the point is you need to know mathematics, which is the case for any course in mechanical engineering. Okay, my email and office phone number is listed here. You can send me an email any time of the day. I will try to reply to your emails in a timely manner in less than a day. So if you don't receive any replies from me in a day, in 24 hours, resend your email. I may have missed your email. And you can always call my office. I will pick up the phone if I'm available. Office hours, the official office hours are Wednesdays from 10 a.m. to 12 a.m. But I'm not gonna sit in my office with an open door. I want you to send me an email if you want to come to my office during the office hours, because things may come up. I may need to go out of my office, and you may miss me if you just come to my office without sending an email beforehand. And also, you can come to my office any other time. You don't need to come in during the office hours. Just send me an email, make an appointment. We can meet over Teams, Microsoft Teams, or you can come to my office and ask your question. You don't need to wait for the office hours. Okay? The point is, make sure to send me an email before coming to the office. My office is in the 300 Main Street building, room A117. Again, you are welcome to come by my office anytime. And if you are just walking past my office, you wanted to say hi, just knock on the door. If I was in, come in. You can have a chat and talk about anything you want to talk about. Any questions so far about the office hours, the meeting times, or the office location? No? Okay, cool. Textbook. We have two textbooks for the course. One is Advanced Heat and Mass Transfer by Dr. Faghi. This is a very lengthy textbook. It's like 1,000 pages. And we are going to mostly focus on the second one, which is called Advanced Heat Transfer, except for Chapter 1, the microscale heat transfer. So essentially what I mean is we are going to use the Chapter 1 of the first book, Advanced Heat and Mass Transfer, as the main text of the course. And then for Chapter 2 and beyond, conduction, convection, two-phase heat transfer, solidification, all of those fun parts. we are going to rely on advanced heat transfer. So chapter 1 from advanced heat and mass transfer by Dr. Faghri, and the rest of the class, advanced heat transfer by Dr. Nater. I don't know how to pronounce his last name, but and both of these books you can actually find a PDF of online. I'm not supposed to tell you this, but you can. Class is going to meet from 1:15 to 2:30 every Tuesday and Thursday. Meeting location is here, which I assume you already knew since you are here. Course topics is going to include an introduction to heat transfer, which is mostly going to focus on micro-scale heat transfer, kinetic theory of gases. Is there anyone in class who is familiar with kinetic theory of gases? That's all right. We are here to learn. So we don't have anyone. And then we are going to move on to conduction. Specifically, we are going to focus on two-dimensional conduction and the solutions to partial differential equations using the separation of variables method. We are going to move on to unsteady conduction and also the essentially temporal conduction, time-dependent conduction. We will move on to convection and force and free convection. So we will usually start with the topics you have seen in your undergraduate heat transfer, which I assume you are familiar with. But we will go over them, we will do a review, very short review, then we will move on to the harder topics, more advanced topics. And so convection is going to be the same. We will do a review of undergraduate convection, then we will do more complicated topics. And we also have the two-phase heat transfer. And there is a course topic that I forgot to add here is radiation. So we will do radiation and two-phase heat transfer. This two-phase heat transfer includes a gas and liquid heat transfer as well as a solid and liquid heat transfer. So we will have solidification and evaporation condensation. So phase change from both sides. And at the end of the class, we will do a little bit of numerical modeling using finite difference methodology, which is the simplest method for numerical modeling of heat transfer problems. How many of you are familiar with finite difference modeling? One person. That's it? Okay. That's cool. You are going to learn, right? Any questions so far? No? Okay. Let's move on. I have the course plan here. I've left the topics blank intentionally because I don't want to rush through anything. And if I see that you guys are comfortable with the topic, I want to rush through it. So it really depends. The topics are going to depend on you and your understanding of the topics, right? So the topic section is blank, but here you just should notice that we are going to have the first midterm exam just before the spring break, which is exactly the midpoint in semester, March 3rd. And the second exam is going to be on April 14th. Assignment, there will be 4 homework assignments, which will contain between 4 to 12 questions, depending on the topic. But there's only 4 homework, so hopefully, and you will get a week to solve the homework problems. And there's also a group project that you need to work on. But I will talk about the group project a little more, also homework and grading. Is there any questions about the course plan so far? Yes?
How is the homework being graded?
That's a very good question. So I usually, as long as you have submitted the homework and you have tried solving the problems, meaning that you have arrived at a final solution, you will get the full points, full grade, right? It doesn't have to be a correct for the homework, only for the homework. For the exam, it's a different ball, right? So the point is, I want to give credit to people who work, right? and you will have this solution to the homework. So even if you get a wrong answer for the homework, you should be able to find the correct solution. So it shouldn't hinder your understanding of the problem, right? A wrong answer on the homework. Does it make sense?
Yeah.
Any other questions? No? Okay, let's move on to grading. Let's see what we have here. Let's talk about the grading and then we'll come back here. Okay. I don't really accept late work, so if you miss a homework submission or a project submission, if you don't come to the exam time, you will get a 0. But I mean, of course, if you have a reason, if you send me an email beforehand and tell me that I got COVID, right, or whatever, but something happened, right, then I will try to come up with a makeup for the exam. But if you don't communicate with me and just don't show up or don't submit something, then you won't get any credit for anything after the fact, right? So you can't come to me at the end of the semester and ask me to give you some credit for homework that you have done 2 months after the due date. Does it make sense? Okay. So please plan accordingly and complete the assignments. The grading has 6 different parts. Homework, 5% each, total of 20% of your grade. Exam 1, 20%, exam 2, 20%, and final 20%. There's also a group project, which is going to account for 20% of the grade. That pop quiz there, which is for 5%, is essentially an attendance check. The attendance in this class is mandatory, but I don't do a roll call. I just do random checks and random quizzes. So at the middle of a class, I may ask you to just tear a paper out of your notebook and solve a problem. I won't grade those, but I will collect them, right? And they will be the basis of your attendance grade, essentially, right? There will be 5 to 10 random quizzes, right? And I usually give out a lot of bonus points. We have 2-3 students who have had classes with me, right? Is it true? We have 3, John, and also John and Daniel, right? Daniel has had many classes with me, right? 3 or 4 classes. So we are super familiar. And he's also going to work on his thesis with me, so. All of you know that I give out a lot of bonus points, right? So if you have messed up a homework on an exam, you can just work on the bonus points, which are pretty simple things. So for example, if I'm showing you the Navier-Stokes and I don't want to drive it, I tell you that you will get bonus point if you submit the derivation of the Navier-Stokes next lecture. And this is something you can just Google and copy off of the textbook, right? You will get bonus points. Bonus points are usually worth 0.5%. You can get up to 20% of your total grade. So let's say your grade is 81 or even 71, let's say 71, and you have 20 bonus points or 40 bonus points, 20% of your grade. You will get an A out of the course. So make sure to work on the bonus points. Again, at the end of the day, the point of this course is for you to learn advanced heat transfer, right? So if you mess up an exam, I'm not going to hold it against you. Unless you don't do anything else. You don't do the bonus points, you don't do the homework, then yeah, you will be punished by a bad grade. And my class is not gonna be like other graduate classes that gives only A's and B's. If you don't do well in the class, if you don't submit the homework, if you don't come to class, if you don't talk to me, you will fail. Okay, does that make sense? It is very easy to get an A, but it's also easy to get an F. So, yeah, you can talk to these 3 people about my classes. We talked about attendance. And one thing that I need to mention about attendance. Let's say you feel tired and you don't want to come to class. That is all right, right? As long as you send an email to me before the class. Just send an email to me and tell me that I don't really feel like it. I don't want to come to class. I'm going to watch a recording. You just have to make sure you submit any random quizzes that may be given using email. Just make a PDF file, send it to me, right, through email or anything else. That is acceptable. Okay. Any questions about the grading? No? Let's move on to project. All of you have to work on a project, and this project has to be original research in quotations. It doesn't have to be a novel idea, of course, because it's just a course, right? I don't want you to submit a research paper here. But you have to do some literature review to see what is out there. It has to relate to heat transfer, of course, or fluid flow, aerodynamics, anything that's related to fluid flow, thermofluids in general. Then you have to submit a proposal. You have to form a group first, right? Do a literature review, submit a proposal. Then you will get feedback from me. And then work on that proposal and submit your final report, and you have to have a presentation. Does this make sense? So proposal, I will upload some guidelines as we go on, but and the due dates are, you can see the due dates in the course schedule. Like for example, you have to determine your topic by January 27th. And you have to announce that topic to me by sending me an email. Does this make sense? Let's say you want to work on boundary layer separation on airfoils, right? On heated airfoils. Whatever that is. Just have to send me an email to me. Send an email to me by January 27th. Also, the proposal submission, all of those things. The guidelines for the formatting, what to include, is going to be posted. But what is my expectation for the project? I expect you to do a literature study. Read a couple of, it doesn't have to be 20 papers, it can be like 2 papers. It can be also a Wikipedia entry, as long as it is accompanied by a paper, is acceptable, right? I mean that the reasoning behind this research review is for me to understand that you have tried to find a novel idea, right? You have at least try. And then you can use ANSYS or any other software to do a numerical simulation, get your results, do the study, and just submit a report. Okay? Any questions? Okay. Is there any questions about the course material or the course in general? No questions. That's good. Everything's clear. Okay, so let's do this. Let's introduce yourselves. Tell me who you are. I assume all of you are graduate students, either master's or PhD. So I assume most of you are working on a thesis or a dissertation. Unless you are a Master of Engineering students, then you can also talk about your future career goals. But tell me who you are, who you work with, and what do you do? And what would you think your your project topic would be? This is just give me an idea. What do you think? I just want to know how familiar are you guys with heat transfer research in general, right? And you don't have to be familiar at all, so don't be afraid. Let's just start from here. And I can introduce myself first, so you'll get an idea, right? It's going to be easier, I assume. So my name is Mustafa Mobli. I graduated from here actually in 2018, and I've been teaching aerospace related courses as well as heat transfer since then. My research is mostly focused on multi-phase flow simulation So this is essentially what I do for research, as well as plasma discharge and aerodynamics. Different topics. Daniel here is going to work on a specific type of boundary layer separation, hopefully, if everything comes together. Yeah, so that's my research. And what else? If you have a question about me, you're always welcome to ask. I can't think of anything else. I remember the project topic. Of course, I'm not going to work on a project, but you have to talk about the project topic here as well. So let's go ahead.
Okay, I'm Claire Dixon. I am a Master's of Engineering student, so I'm not doing any research.
Okay.
I've never done research, so I don't really know anything about this. My primary interest is in thermodynamics, particularly with liquid propellant rocket engines.
Okay. That's interesting. You can definitely do your research project, your course project on that topic. I don't know how you can simulate it though. But you can always come to my office. We can talk about it. If you are confused about your topic. Let's say you are interested in a liquid propelled rockets, right?
Mm-hmm.
Is that that's what?
Yes.
And you want to do your project on that topic. This is something I can definitely help you. So send me an email. We'll set a meeting, and we'll talk about it. We'll see how we can. Claire.
Okay. My name is John, and I'm a PhD student. Now, my project is about the electromagnetic, electric heat transfer, and solidification, and melting, and something like that. And when I was a master student, I focused on the pump, cavitation, or fluid dynamics, nothing about heat transfer, but I learned something because it's necessary classes, but just to know something about that. And now, what I'm doing is about the heat transfer. So I think.
Who do you work with?
You mean my supervisor?
Yes.
Professor Lang Yuan.
Yeah.
Yeah. So yes.
Okay. And what do you think your course project would be? The topic of your course project? What are you interested in, or what is easier for you to work on?
I think I have several topics. I mean, I know it a lot. So if you ask me now, I think maybe solidification.
Solidification.
Yes, boundary or several boundaries, some boundary conditions, some initial conditions, and use the Fluent software Fluent, we can get a traction result. We can know the process of the whole process. Yes.
Thank you. John, you said, right?
Yeah, John.
Hi, my name is Malhar Joshi. I'm from India. I completed my bachelor's from India, and I'm currently doing masters of engineering over here.
Mm-hmm.
So I don't have any thesis or dissertation as of now, but I would like to do something related to maybe airfoils and pattern surfaces to reduce drag. So, with regards to the project, I think I would like to take that topic. I'm not sure how relevant it is to the subject, but it is something related to aerodynamics, and it's mostly about reducing drag rather than anything about heat transfer. So if it matches, I would like to pursue that as the project for this class.
Okay. Sounds good.
My name is Mohammed Al-Fadi. I work under Dr. Ming Yu, and my research interests are in computational material science and machine learning. That's all.
So what do you want to work on?
Predict material properties using machine learning.
Material. That is related to heat transfer. As long as you predict conductivity, right?
Thermal conductivity,
Okay.
other
Sounds good.
properties.
It doesn't have to be a full-fledged project as long as it's a rough idea. If I mean, you can tell me I don't have it. I don't know what I'm going to work on. That's also acceptable.
Okay, my name is John. I'm a graduate student. I am in ME, so not doing any research, but interests are fluid flow, boundary layer separation, heat flow or transfer through like a wall or pipe insulation. So thinking maybe do something similar to that for the project.
Okay.
My name is also John. I'm a Master's of Engineering student. I graduated with my bachelor's in 2020. It's fingers crossed my last semester, so I'll be graduating after this semester. In terms of the project for the class, I'm not really sure. I think, and I tried to do, I think the same project for our aerodynamics class. I think something with like a satellite or a spaceship re-entering and those stresses, those like extreme case scenarios would be interesting.
You can actually do a shock wave analysis, huh?
What was that, sorry?
Shock wave analysis.
Sure, yeah.
That's
Just anything with like an extreme use case like that would be pretty interesting, but I know that a lot of theory falls apart at those boundaries, so maybe it's not really feasible, but I think it'd be cool.
yeah, it definitely is feasible. Though.
Cool.
My name is Teddy Tarpin.
What was your first name again?
Teddy.
Teddy.
Yeah, Teddy
Okay.
Tarpin. I just started my master's this semester, and I'm working under Dr. Herrick. Right now, I'm working under Dr. Herrick in automation and PLC programming,
Mm-hmm.
but I don't really have that much background in heat transfer, but I think it'd be interesting to, I always thought it was interesting to like try to build my own like biomechanical device. So I think maybe looking at the fluid flow for something like that, something that would be, you could integrate with the human body.
Yeah, that
to
should be
get to
alright.
Consider a lot of those things.
Yeah, that's cool.
But yeah.
Okay.
I'm Dana Monteith. As Dr. Mobley said, I'm working with him. I'm a master's student. My focus is going to be on boundary layers, like he said. For the project, I probably will be doing something on boundary layers and boundary layer separation. But the extreme environment situation that John was talking about also interests me. And when I'm done, I also have a degree in chemistry, so right now I'm thinking about like doing hypersonic research once that friction is taken into account.
Okay. Cool.
Hi everyone, my name is Chidoba Omoka and I'm from Nigeria. So I'm a master degree student. I'll be completing my master this semester. I work with Dr. Kidani, Adif Kidani, and my research is focused on dynamic behavior of energetic material. My thesis is also focused on effect of particle size on the deformation mechanism of polymer bonded explosives. So I think this is my first course in heat transfer. I don't really have a solid knowledge of heat transfer, so I can't think of any project I can do now on heat transfer.
Okay. Sounds good. You used to be heat transfer TA for the lab, right?
Yes.
Are you still a TA for that lab?
Yes.
Okay. Sounds good.
But I don't know if it's gonna be heat transfer.
Okay.
I can change to maybe another.
My name is Shane Ennis. I work under Dr. Fujitsu. I'm a master's student. I work with structural health monitoring right now and some with composites. So in the project I'd be interested in something to do with composites, whether it's the oven process. I think that'd be kind of interesting.
Sounds good. Yeah.
My name is Jason Pathos. I'm in the Technological Innovation Engineering program. I don't work for anyone right now, but looking to get into an internship for a nuclear company in Maryland for this summer. For the project, I'm not quite sure if it was something with the structural integrity of a pressurized area, something along those lines. Not really fully defined yet.
I mean, you have to be able to relate it to heat transfer in a way, right? Or fluid flow.
Or like superheated.
conditions.
Okay, that's cool. Thank you. You have to speak up. Okay, energy systems.
Hello, my name is Kuman. I'm from Iran, and I'm a master's student here. I work with Dr. Nasiri, and actually I design cooling system for a transformer. And about this project, I don't have any idea yet.
Okay,
I think I should think about it.
that's fair.
My name is Roya Rajavi. I'm working with Dr. Khan and Dr. Khan. And my PhD project is to work on zinc ion battery to improve it to be able to run in higher temperature without the thermal running. Actually, it has two sections. One is experimental and the second section is simulation. Because of this, I took this course. I'm unable to project of this course. I'm not sure if so. Maybe I need to talk with you or my advisor.
Okay,
Select something with it.
okay, sounds good.
My name is Luke Bagan. I'm a first semester master's student, and I'm working with Yi Wang. I'm doing research right now on neural networks and machine learning for autonomous vehicles.
Mm-hmm.
I don't have much experience with heat transfer, so I'm still trying to think of what I'm going to do for the project.
Okay, sounds good. So, a little bit of introduction. Hopefully by the end of the semester we will all know each other a little better. And so the first thing you need to do for the course, it's also related to the project, is to form your groups. We have 17 students in class. A lot of them got COVID. I mean, some of them got COVID, didn't show up to the class, but they have to also form groups nonetheless. So you have to make sure you send me an email by Thursday, so in 2 days, and let me know who are your group partners, right? I mean, a lot of you don't know each other, but try to get to know each other a little more, and try to form groups of 2 students. One of the groups can be 3 students, or it can be someone who is only going to work on the project by themselves. So we can have a sole member project, 1 member project. Yes.
There should be 18 students, right?
Oh, including you. There will be 18. So there's no problem there. 9 groups, right? And I expect to know the groups by Thursday. So send me an email and let me know who is your group partner. And well, so that's the first thing you want to do. And the second thing you want to do is to work on your topic. After you have formed your groups, if you have a topic in mind, send me an email by 27th and let me know what your topic is. If you need some help for your topic, we can always meet. You can come to my office and we can meet and talk about your project topic. Project is very important to me, as you can tell. I've been talking about the project for a while now. So make sure to put the effort and work on the project, right? You want to have a good submission. You have a question?
We don't have enough space for 18 people?
Yeah, that's a good point. I will talk to the department and see if we can change the classroom. I really don't like this classroom myself. And if we couldn't find a proper classroom, we'll probably go to any conference room. I will see if I can reserve it. That will have enough space for 18 students. Okay. Thank you for bringing that up, though. Okay. Any questions? No, none. No questions about the lecture, about the class. Okay. If that's the case, let's. As I said, this was supposed to be a very short lecture today, and it just ran for like 40 minutes. This is what I thought, and I'm going to see you guys next Thursday. Make sure to send me the email with your groups to announce your group members, and we will start working on micro level presentation of heat transfer on Thursday. Micro scale presentation. Any questions? That's it. Class is dismissed. Yes. Pardon me?
When should we send you an email for the group?
By Thursday. See, this is, so on the syllabus, the due dates are listed here. So group submission by Thursday.
Is that during, before class or?
Before class. So all of the due dates are before class. Whatever that is due before class. So due by 1:15. Homeworks, projects, groups, topics, whatever. Okay? Okay. That's it. You can